Okay, so we are presented with another question here. Just know that these are sample revisions, okay? But we do more in our online classes. Come and join us. Very affordable. I'm going to show that it is very easy to get a distinction in mathematics. Let's go. Then you are going to confirm by the end of the video that the SI is actually right. The diagram below shows the region R bounded by 3 lines. So you can see this line, and the other line. It's up to you. You can label them the way you want. Whichever here can be your line. Doesn't matter. So guys, what you're going to do here is this. Let's label the simplest line is what you start with. You can start there's this line which is being shaded to the left side. So let's call it line 1. So let's call it line 1. Next we can call whichever as line 2. Let's call this one line 2. We are going to go, clockwise. Then we call this one our line number 3. So let us start with line 1. Okay? So line 1. You can see that the line is actually perpendicular, meaning it's cutting through the x-axis. It's not cutting through the y-axis, it is cutting. Any line which is like this, it is cutting through the x-axis, meaning that line is equal to x equal to, where is it cutting? 0. But we are looking for the what? Inequalities. Are we there, right? For the what? Inequalities. Now, again, in as much as we are looking for the inequalities, we are looking for the unshaded region, meaning you don't get what has been shaded, you get the opposite. Are we together? So x is equal to 0. Which side are we looking for? Are we looking for this side, or we are looking for that side? You are looking for the side where R is. Is R on this side? No, but R is on this side. So we are looking for this side, meaning this is our interest, the upper part. Remember, as my arrow goes up like that, the numbers are increasing here, meaning I'm going to the right part, meaning my x is greater than or equal to 0. Why am I using greater than or equal to 0? Here's the thing. When your line is straight, you use this or that. When your line is dotted, use that or that. Are we clear? And you can set my line is, and we are looking for the side where R is, which is the greater than part. We go to line number 2. How far so far? Are we convincing each other? Let's go to line number 2. So line number 2, we are going to pick 2 coordinates because this line is not just cutting the the x or y plane at one point, but it's cutting at this particular point, which is 0, 0. It's also cutting at this particular point, which is that, and that, which is already given as 5, 4. 5, 4. Meaning this line deserves an equation. How do we do that? Get back to coordinate geometry, where you find the gradient first, where we said gradient is given by the change in the y-axis over the change in the x-axis. All right, so now we substitute. y2 is this one at the end, therefore. Why did I put these numbers at the end? Because the line is increasing, is going up. The line, this one, which is going straight like that, is, I said, different issue again. So the 0 over 5 minus 0, m here is 4 over 5. That's our gradient. Now that we know the gradient, let's proceed into finding the equation. So now we're going to say y minus y1 is equal to m x minus x1. So y minus y1 is 0. The gradient is 4 over 5. And by the way, it should be positive because the line is going up. If you find that the gradient is negative, but the line is going up, you're doing something wrong, my dear. X minus x1 is also 0. Meaning we have y is equal to 4 over 5 x. But we are not interested in the equal sign. So which sign are we going to put there? Now come here. Which side have they shaded? They have shaded the down part. Are we interested in the down part? No. Our R is not this side, no. Our R is up there. Our R is up. by the issue of saying up, our arrow is on the side which is the greater. And our line is dotted, so we use the greater than part only. So we are saying greater. You are done. Just like that, you are done. Our line number 3, I'll put here. Line number 3, same scenario as line number 2. It's the same way, because now this line is going down, meaning this is our starting point, 0, 4. And this one here as our ending point, 5, 0. How are we moving? Are we together? I hope we are together there. Now we do the same, we find the gradient. Now our gradient here must be negative because the line is sloping down. So we get that. x2 and x1. Our y2 is 0. Our y1 is 4. Our x2 is the number there, 5. Our x1 is 0. This will give us -4/5, which I said should be the answer of the negative. Now, going to the equation or the equation formula, minus x1. I like to use this one because it really gives me less pressure, you know. Yeah? y1 is 4. Gradient is -4/5. x1 is 0. Meaning -4 will go the other side, meaning I'm going to have this is equal to -4 5x plus 4. Am I interested in the negative? No, sorry, in the equal sign. Not at all. Let's go back to the diagram. They have shaded this part. We don't want it. We want the part which is down below. And we are going to use this one because the line is dotted. Meaning our answer is y is less than -4/5 x plus 4. Yeah, I know. My number is here. I know. Tefio. Convinced, Tefio? Come. I don't just teach mathematics. I teach physics, chemistry, biology, English language for grade 12s. You know the right man for the job. Come closer.